I never had this much trouble, and I taught Twilight for 10 years.
Oh my God.
10 years I did Twilight and never had as much trouble as this year. The kids are horrible this year. Horrible. But you guys are not. So I'm so thankful when I'm in my classroom and I'm with my kids that I love. Yes. Okay. You're the only guys that make me get through my days. All right. So let's walk through what you had for homework. All right. Combinations. Combination says order doesn't matter. So no, that's not true. A permutation says order matters. A combination says order doesn't matter. We talked about these, that when your numbers, these are like your R's, when they add up to the same end, their combinations are the same. It's just the way the combinations work out. Everybody can put these in your calc. Just a matter of putting them in your calc. Good. Same thing with 11, 8. Can you put them in your calculators? Okay. What's the difference between doing it this way and doing it this way? This gives me what? A high number. So this is usually my how many ways, or my different combinations.
That's the probability.
And this is a probability. So whenever it asks for a probability, it has to have a bottom number. It has to be less than 1. And if your calculator gives you 1.13 and an E, make sure you pay attention to what this E says, because this E moves your decimal place, because your probability can never be higher than 1. Your probability can never be negative. The number of ways 8 cars can line up for a car wash, permutations. 8, you can write this a number of ways. If you get confused, the word lineup says, I've got some kind of a line, some kind of an order. Who's first on line? Remember when you were little, I want to be first on line, I want to be line leader? Whenever you have a line, you want to be first on line, whatever. So make 8 if you struggle. And then work it down. 8, 7, 6, 5, 4, 3, 2, and 1. Sometimes as soon as you start writing and you realize you're going down, you realize this is a factorial, or permutations, 8 things, 8 at a time. Whatever helps you remember that. A 4-member committee says, doesn't matter what order you sit on this. This is a combination.
That's a 0.
I know. I don't know how I got a 0 in there. 10 things, 4 at a time. Are there more permutations of 10 things 4 at a time, or more combinations of 10 things 4 at a time? What's the other word? Permutations. Combinations takes out the duplicates, remember? I can have AB, BA for a permutation, but for a combination, I can only have it one way. It doesn't matter to me what way it is, because it's the same group of people, right? So I have less combinations. The starting lineup for a softball team, again, here's the word lineup. A softball team consists of 10 players. How many different orders are possible? It's a lot of ways you can line up those 10 little people. Okay? And if you have trouble, start with 10 lines. And once you start going like this, you realize you're going to go all the way down. 10 factorial, or write it as a permutation. Are we good? Stop me if you're not good with these. I told you when we first started doing this, I was always blown away by how many numbers there are for these things. How many possible combinations and different ways to do this. There are 50 runners in a race. How many can finish first, second, and third? Well, does it matter to you if you finish first or second? Yeah, so order matters. This is first place, second, third. Multiply them down. Order matters is a P. 50 things, 3 at a time. An archaeology club has 38 members. How many different ways can you seat 4 people? It matters who's president, who's vice president. This is your P. Do 38 things taken 4 at a time. Make 4 lines. Everybody comfortable with the 4 lines? Because whenever you struggle, make the lines. Okay, the distinguishable permutations. This one's a little tougher to see with the charms. I always find it easier if we look at words. Yes, because remember we did this one with the shrubs? We had elm trees or oak trees. We said 6 of them, 10 of them, whatever they were. It's easier when you look at words. Like say the word bracelet. If I wanted to make different word combinations, this is 3, 6, 11 letters, right? If I change this E, did you notice that was different, even though I changed my E's? No. So we want something that's distinguishable. So we don't want to count those 2 things that we changed. So therefore, anything that repeats itself, like an E, there's 2 of them, I'm going to take out that factorial. So what this is saying is all your spacers are going to look the same. Technically, your gold charms are just going to represent your gold charms. Your 8 silver charms, they want to make it distinguishable. So you're going to have to take out these factorials. This was hard to see, but they did tell you distinguishable ways. Once they use the word distinguishable, you're taking the duplicates out of the denominator. I think the letters are just so much easier to recognize because you can see when we switch an E. Like a charm, if you had 5 gold charms and then you put a spacer and you did 4 gold charms, if I switch any of these 4 gold charms, you wouldn't notice the difference. You'd still see 4 all put together. If I switch these spacers, you wouldn't notice the difference. So to take out the ones that are duplicating, you take these out. Be careful in your calculator again, because if you do this, 22 factorial divided by 4 factorial, 10 factorial, 8 factorial, it's technically left to right. It's going to do this first, and then it's going to multiply that answer. So if you're going to do this, make sure parentheses go in your, you got to do this with the block calculator, 83s. You got to put parentheses here. The 84s, you can use your fraction key. But if you string it out, you've got to use parentheses. From a group of 40 people, a jury of 12 people are selected. How many different ways can we select them? Does it matter what order they sit on a jury? No. So you say that right away. As soon as you say order doesn't matter, you put a C. I have 40 to choose from. I want groups of 12. It's a lot of ways to make your groups of 12 and 40 people. A lot of ways. Would you think it would be that high? I would never think these things were that high. And I've been doing this for years. Everybody still good? Okay. A restaurant offers a dinner special that lets you choose from 10 entrees. This one was a little confusing. 8 side dishes and 13 desserts. You choose, you choose 1 entree. I think we did this again together. And 1 side dish, but you choose 2 desserts. How many different meals are possible? Usually our counting principle says 10 times 8 times 13. I want 1 of each. But this time they wanted you to choose 2 desserts. My favorite kind of restaurant. So now we have a 10 and an 8. And you can choose 2 desserts. So it's going to give you more than 13 combinations there. So does it matter what order you choose your desserts in? So combinations of 13 things, 2 at a time. That one threw a little curveball at us. How many of you got that one? Good. Very good. That was tricky.
I did it, but I just did permutation instead of combination.
Oh, okay.
Yeah.
So you like to eat your dessert in special order? Yes. So if you justify that to me, say, yeah, I like my dessert in a certain order, I would take that. Okay. An environmental agency is analyzing water samples from 80 lakes. So your total lakes are 80. 5 of these lakes have dangerously high levels of dioxin. 5 of these are polluted and toxic, whatever you want to call this. So therefore, 75 of these lakes are okay. They're not polluted. How many? 6 lakes are selected at random. So somewhere, either a P or C, this is going to be my 6. Okay. So now, How many ways could one polluted lake and 5 non-polluted lakes be chosen? So you want one polluted lake. How many polluted lakes do you have to choose from? 5. How many non-polluted lakes do you have to choose from? Does it matter what order you choose those in? So we're not going to use a P, we're going to use a C. Now, these guys add up to 6, see it? But we had 2 interesting things. We had 1 polluted, 5 non-polluted. So just separate these. Just separate them. Choose 1 from your 5, choose 5 from your 75, and multiply them. If they want ways, be careful if they want ways or probabilities. Sometimes they say, what is the probability of? And if you guys asked me yesterday, I might have did the probability. The probability of getting 1 polluted lake and 5 non-polluted lakes. How would I make this into a probability? What would be my bottom number now? What would be the bottom? The generic part, not it. It would be 80 C 6. Good. Any 6. My generic number, any 6. I helped you yesterday. I think I made this into a probability. If anybody asked me. I probably didn't read it all the way. Okay, so make sure you know the ways versus the probabilities. The U.S. Senate Select Committee on Ethics has 6 members. Each member is equally likely to serve. They usually throw that equally likely so that you know your probabilities are the same. What is the probability? This one wants a probability of randomly selecting the current chairman and the current vice chairman. Right now, 2 people are sitting there. There's Pete and there's Andy sitting on this committee. Okay. What is the probability that I'm going to select just this set? This only happens once. I can't switch them around. That's a different time. So I figure out how many different ways first. Can I do 6? Does order matter on this? Yes, order matters on this. So I can do this first. 6 things, 2 at a time. I could lay out my lines. This is my number that I'm looking for. That group, Peter and Andy, Peter as chairman, Andy as vice chairman, only happens once. So my probability that I select the current one is 1 out of 30. They like asking those. You should say the current. Good so far? Yeah. These are tricky. This is probably like the hardest parts. A pizza shop offers 9 toppings. No topping is used more than once. What is the probability that the toppings on a 3-topping pizza are pepperoni, onions, and mushroom? Does it matter what order I put those on? When you call for a pizza, you say, I want a pepperoni and mushroom and onions. Do you say, please put the pepperonis on first and the mushrooms and the onions? No, they just sprinkle, right? Because it all kind of bakes in. So first we determine order doesn't matter. That's our state. Order does not matter. How many toppings do I have to choose from? 9 toppings. How many do I want to put on here? 3. This is going to give me how many ways I can make a pizza with 3 different toppings on them. Doesn't matter what order I put them on. How many of those pizzas have pepperoni, onions, and mushrooms? 1 of them. There's my probability. Find your ways and then take that exact one, just like the other one. You can do with permutations, you can do with combinations. In the past, I always find kids have a hard time with this test. Everybody getting this? That this is the one particular one they want out of the 84 the ones that they could possibly make? If I was looking to find out all 84 possible pieces, how could I do that? Tree diagram. I'd have a large tree, but I'd start here with me ordering. I'd have 9 off of these. And then I would say pepperoni, onion, mushroom, blah, 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 blah. That'd be my first one. How many branches would I have off the second one? 8, because I can't repeat. Then off of those, I would have 7, because I can't repeat. That would give me all my different ones that I could get. Now, the only problem with doing this tree is order makes a difference on this tree. We would have to then go take our sample space and take out all our duplicates. Does that make sense? We would say pepperoni, mushroom, onion, onion, pepperoni, mushroom. So we would have duplicates in our tree. But it would help us at least get started to see where we were going. Combinations generally don't work off of a permutation tree, but it kind of helps you just put it in perspective, where are those coming from, so that you get something like this. Okay, the offices of president, vice president, and secretary for an environmental club can be filled from a pool of 14 candidates. 6 of those candidates are members of the debate team. What is the probability that all of the offices filled by the members are members of the debate team? I want a probability. So the first thing I want to do is part over whole. This is my probability. This is my generic part. This is my particular part. This is my generic. And then this is the piece that I'm looking for. Go for your generic first. Some of these questions, you'll see they'll say A, how many teams can you make? B, what is the probability that? So sometimes they lead you into that. So the first thing I have is 14 people. Any 4 of the 14. Whoops. Yep, any 4 of the 14. I want, how many do I want? 4. Excuse me. Any 4 of the 14. This is my bottom number. This is this. And do you have to do the whole thing? You can do it this way if you like. How many of them are on the debate team? 6 members of are members of the debate team. And how many do I want? 4. So you can set it up like this. I set it up separate so you would see the difference in how many ways and find the probabilities. What are the probabilities that none of the offices are filled by the members? So if they're not members of the debate team, then they're non-debate. So I could take 14 minus 6. 8 people qualify for that. I got the same denominator though, right? Same generic denominator. So now I'm just, my numerator says this over my generic denominator. And I like the decimals because you can see them a little bit nicer. One had a 1.5%, this one had a 7%. So yeah, because there's a lot more people that are non-debaters. The probability that you pick 4 from 14 and they're all the same is a small probability. Everybody get these? These are a little tough. 44. Okay, so how many positions do you have to fill? You have 4 positions to fill. I want to select what is the probability, and they didn't ask me who they will be, so normally this is a permutation. That's why this is confusing. Normally this is a permutation. Who's secretary, who's president. But they're not asking me how many different ways can I fill them. They're asking me, out of 14 people, 6 are debate team people. Therefore, 8 are whatever else is left is my non-debate team people. They're asking me a combinations question because they're asking me, of the 6 members that are debate team, what is the probability that when I fill these offices, that way they will be from the debate team. And I don't care when I say debate team, what order they sat in. They took a permutations and they made it into a combinations by the way they worded it. That's why these are confusing. Because the first thing we do is say, oh, order matters, permutation. But they're not really asking me that. They want to know what is the probability that all the offices are filled. They don't really care what order they're filled in. They just want to know, of the 4 positions, are they all debate team members? So of my debate team members, so this is where we say debate team over generic. If you start like this, part over whole, this has to be your generic, any 4. This has to be your specific. Because the bottom one always has to be the generic, the big number. This is going to give you a far bigger number, right? Because now you have 14 to choose from. And the small number goes on the bottom. This is specific over generic. Somewhere put this down. Generic is any 4. Specific is 4 people from the debate team, from the debate members. My debate members have 6 to choose from. Does it matter what order I choose them? I don't care what order I choose them, because I just want to know, are they all debate members? Yes, sir. Okay. We okay with this? This is confusing. You have to determine, are you looking at a permutation? Are you looking at a combination? What did I give you up to? What number? 48? Okay. So 45, you can choose 4 people at random from a group of 1,200. What is the probability? Oh, you must have a pie chart there, right? Yes. You have a pie chart here. Okay. So the percentage they rate as excellent is 7%. This one is confusing also. Okay, so now you have a group of 1,200 people. What is the probability that all 4 would rate their financial shape as excellent? So first of all, I need to know how many people rated this as excellent. So from 1,200 people, I say 7% of 1,200, 84 people said excellent. Because when I make my probability, I made specific over generic. These are my any 4. I don't care what they said. My top number is just the financial part. That said excellent. Okay. And here's a good case, too, of what your calculator does. This comes out of your calculator. Your probability cannot be greater than 1. So keep looking. It had an e to the negative 5. That's a scientific notation that says move this 5 places to the left, the decimal. So you're adding 4 zeros. It's always 1 less space. So if you move 5 spaces, that takes care of the number, and then 4 zeros. If you want to leave it as a scientific notation, that's fine, but I would kind of prefer that you understand what's going on. This is tough. These were tough ones. Agree? Okay, it gets a little tougher. So I gave you 48? Okay, so 48 says choose 55 people at random from a group of 500. They changed this on us, but we're still using the table there, right? Am I still using the table? Yeah. What is the probability? And I think we do this one in class together? I think I did it with the other group. I wasn't fond of this because they also threw a not in there. And doing a not at the same time is a little bit more difficult. They said you choose 55 people at random from a group of 500. What is the probability that none of the 55 rated their financial shape as good? So the first thing you do, your generic number underneath is any 55. This is generic. Any 55 from the 500. I would never give a sentence like this because I don't like the not and the whole thing at the same time. Again, it's a combination because we don't care what order we select them in. Good was 32%. Well, we don't want the good. We want everybody else but the good. So here's your complement case. This was your complement case. So first we had to find everybody else but the good. And we had to figure out how many people are we talking about. Out of the 500, we're talking about 340 people. So specific of those 340 people, I want 55. The not is the none, the not is the confusing part. Because remember up here, we wanted the people that were excellent. So out of a group of 1,200, how did I know how many people were excellent? I took the percentage, right? So this says if I wanted their shape as good, I would take 32% of 500. However, they wanted the ones that were not good. They wanted the complement of that. We could add up all the other things, except for the good, or we could subtract it from one. It is a very, very confusing problem because they threw the not in there. I would never give a problem like this. Okay. I did want to hit these guys. I did want to hit these guys. Do we have time? Can we hit these? Yeah, we do. We have time. 5 minutes and we're done. It'll only take me 5 minutes. Please write these down. These are tough, so I wanted to go through these with you instead. Page 177. Warehouse employs 24 workers on the first shift, 17 workers on the second shift. So start out like this. I don't know how many workers there are in total yet, right? I need to know my totals. 8 workers are to be chosen at random and to be interviewed. Do I care what order I interview them in? So I know I'm a combination. Okay? So I want to interview 8. Find the probability of choosing 6 first shift workers. How many people do I want in total? 8. So 8, this is my bottom number. This is my generic. Any 8. Give me any 8 to choose from first. I have 41 total people. Any 8. So go like this. I want 6 first shift. I need them to add up to 8. So how many do I want on the second shift? 2. Start like that. 2 from my second shift. So any order. How many first shift people do I have? 24, and I want 6. How many second shift people do I have? 17, and how many do I want? 2. There's my combination. Are we seeing this? Write this down.
I know that you multiply them on top.
Well, because it's an and statement, I want them both to happen at the same time. I need 8, and that's a very good question. And or I would add and I have to multiply. Anytime you build it like this on the numerator, you're gonna add them. Find the probability of choosing 4 second shift workers. So again, I want 4 second shift. I need this to add up to 8. How many first shift workers do I want? 4. Any order. How many second shift workers do I have? 17, C, 4. How many first shift workers do I have? 24. I want 4. That's how I want you to set them up. Generic, any 8 at all. I don't care who they are. That's my bottom total number. All the possible things that I could get from any 8. My top is my specific part. Okay? And one more. This one's a really, really important one. Can you see this one? A shipment of 10 microwave ovens contains 2 defective. So, again, 10. 2 defective. How many of these microwave ovens are good? 8. Is this a good probability for when you go buy your microwave? No, that's a 20% defective rate, right? That's why I always pick the one that doesn't work. So, the restaurant buys 3 of these units. What is the probability of buying at least 2 non-defective units? If I want at least 2 non-defective units,
I'm buying 3. What is the only case I don't want? Well, in this case, like, there want 2. I want 2 non-defective, or what? Here's my or condition. Or at least means that or more, save money in your pocket, or 3 non-defective. Okay? So I want either 2 non-defective in this group or 3 non-defective in this group. So this is my and condition. So all I want to do is get you thinking this. This is where, when Sarah said, how do we know we multiply? Because that's an and. This is an or situation. But we have to build the 2 non-defective first, and then the 3 non-defective. And then we're going to add those probabilities together. Okay? I know these parts are